All right, so nobody really likes adding together vectors in 2 dimensions, but it's one of those things in life you have to do. So I'm going to walk you through a problem here dealing with the conservation of momentum in 2 dimensions, which are always the more interesting problems. So here's a little example of a problem. It's nice and Spartan. There's not a whole lot of words. Basically, we've got 2 objects, object E and object F. We know their masses. We know their initial velocities. We know the angle they're coming in at one another. They're going to hit, and they're going to bounce off of each other. We know the velocity of object F and the angle that it's going to move at. We don't know anything about E, and that's what we're going to try to find. When we start problems off like this, what we want to begin doing is breaking each of the momentum vectors into x. So there's one x, there's another x, and y components. So there's a y, it's going up, another y that's going up. Oh, sorry, that one was obviously going down. There we go. Now, to go through and find, let's say, our x components first, in this triangle here I've got 20 degrees, and next to that is the side that I'm looking for. So I'm going to use the cosine ratio. So I think I can fit that in over here. Cosine of 20 degrees times, and the momentum of this object is 3 times 5 is 15 Newton seconds. So there's 14.0953. 14.0954 Newton seconds. Maybe now I'll find this this x component down here. This one's cosine again. And here we have 5 times 1.5. So let's just double check here. That's going to be 7.5 Newton seconds of momentum. So it's 3.75 Newton seconds. Now we'll go in and we'll do the y's. Pretty similar. The nice thing about the y's is all you really got to do is change cosine to sine, and you get the y components. Now this y component is going down, so it's going to be a negative value. Put my bracket in there. So 5.1303 going down. And for the other one here, it's going up. It's going to be positive. It's going to be sine of 60 degrees times 7.5. $6.4952. We got one more set to do over here. I've got a downwards y component. I've got an x component. Find those. So for our x component, we're going to use cosine. And the momentum after collision is 4 meters per second. And this has got a mass of 1.5. So 4 times 1.5 times cosine of 50. So that's times 4. So that panned out to positive 3.8567. And the y. So 4. 4.5963 Newton seconds. And that one is also going down, so I got to put a negative sign in front of that. There's a big fat negative sign right there. Okay, that's all the heavy lifting done now. Now we can start to deal with the actual conservation of momentum idea. So let's do the x direction first. The sum of the momentum initially in the x direction has to equal the sum of the final momentum in the x direction. So what's my initial x momentum here? We've got 3.75. And we've got, what was the other one there? 14.0954. 14.0954. And in the x direction over here, we had, what was it? 3.8567 Newton seconds. And some momentum that we didn't know from E in the x direction. Some other momentum that we can solve for with this statement. So there's my x momentum that is unknown. And I can go through and solve for that now, just by doing some basic kind of algebra here. So it's roughly 13.9887. We're going to do the same thing now in the y direction. The initial momentum in the y has to equal the sum of the final momentum in the y. So initially we had 6.4952. And we had a negative momentum from the first one here, I think. Yep, negative 5.1303. Then after collision, we had a negative momentum, negative 4.5963, and some momentum from E prime, some other y momentum that I don't know. And so that's what I'm going to solve for now. So it will be, let's see here. All right, so it looks like it's positive, which is what we want. 5.9612 Newton seconds. All right, whoa, that's a lot of work. But now we can go up and we can finally find the resultant velocity and resultant momentum. So my x momentum was, let's just call it 14. That's going to be probably good enough for our purposes. 14 Newton seconds. Our y momentum of the other object was about, let's say it's a 5.96. Now we can find the resultant. For that, we'll use the Pythagorean formula. I don't usually go through and show my work for this in my class. The kids usually seem to see what's going on. So 15.2 is what we're getting here for our resultant momentum. And if I divide that by the mass of E was 5 kilograms. That's a little over 3, I think. Yep, about 3.0 meters per second. For the angle, because we'll want that too, I'm going to use the inverse tan function of the opposite side divided by the adjacent side. So it's about 23 degrees north of east. All right, there you go. Well, I'm tired and I'm like all sweaty from doing all that work, but we were able to find we're able to find our resultant velocity and momentum, our resultant angle. For a little bit more practice with some of these 2D momentum problems, you can check out my website, www.ldindustries.ca.